Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy. And from last class we started about discussing on the system tracts, and this will be a series of classes, and within this series of classes we will be discussing about the different types of system tract. And as part of that series of the system tracts, today we are going to discuss about the first one, the high stand system tract, abbreviated as HST, high stand system tract. So, the high stand system tract, this commonly forms during the late stage of base level rise. Already we know about that if we refer back to that fundamental base level curve, within that curve when it is near to its maximum, when the base level is reaching to the maximum level, maximum height, but the rate of base level change is quite low, at least lower with respect to the rate of sedimentation. In such condition, we get a normal regression of the shoreline, and that particular phase just before the turnaround of the base level, that is the start of fall of the base level. So, that particular phase is called as the high stand system tract. So, it is lying in between a TST at the bottom in the lower part, or rather underlying unit is the TST and the overlying unit is the forced regressive part, which may be represented by FSST or which may be represented by some erosional surface like subaerial unconformity. So, within this normal regressive package which is forming within the high stand system tract, within this the depositional trends and the stacking patterns, they are dominated by a combination of aggradation and progradation processes, because during this phase the base level is very high. So, that allows some extra accommodation where sediments can accumulate, and since the sediment supply is very high, so we can get aggradation and also we get progradation. So, during this class, during this discussion, we will see that how this aggradation and progradation takes place and how in different parts of the basin we get deposition under this HST system. So, as the accommodation is made available by this rising sea level, however, that sea level is rising, but it is decelerating, the rate of rise is decreasing. So, that base level condition results in high stand sedimentary wedge. Now, this sedimentary wedge, which we call as the high stand sedimentary wedge, it forms because of this aggradation and progradation, and it is generally expected to include the entire suite of depositional systems starting from fluvial to coastal to shallow marine to deep marine, starting from continental side to the marine side. Across this entire stretch we get deposition as per the conditions prevailing in these individual environments. So, within this high stand system tract we get series of depositional systems starting from fluvial depositional system, coastal depositional system, shallow marine depositional system, deep marine depositional systems. So, this HST comprising of these variation of depositional systems, these are commonly bounded by, at the bottom part, by the maximum flooding surface. As we already know that the transgressive system tract underlies the high stand system tract. So, the boundary is maximum flooding surface, which is bounding the bottom contact of the high stand system tract. And if I look into the top part, the upper boundary of this HST, it can vary. It can vary from area to area, from depositional system to depositional system. For example, when we look into the continental part, into the fluvial part, there commonly it is represented by subaerial unconformity that we have already discussed during our classes on different types of surfaces. In some part, particularly in the shallow marine part, in the self part, even in the deeper marine part, we can get BSFR, basalt surface of forced regression, which demarcates the start of the forced regression. And in some portions, particularly in the shallow marine part, where we get successive wave erosions, wave reworkings during this falling stage, that can result in regressive surface of marine erosion as the contact. So, basically what we get over here as the upper boundary of the HST, it is commonly represented by a composite surface. In some part it is an unconformity, in some part it is a basal surface of forced regression which is a conformable contact, and in other part it is an RSME, again an erosional contact. So, if I look into the strand planes, that means when I am looking into the open shorelines or when I am looking into the delta systems in the river mouth settings, all these systems will prograde and downlap the maximum flooding surface, because that is the substrate at the beginning of the high stand systems tract. So, that marks the lower boundary of the HST of the normal regressive package that is forming during the high stand, and during this phase successive packages starting from delta to open shoreline condition, all the sediment packages, all the depositional systems will try to prograde, and when they will be prograding, the clinoforms will downlap on the substrate which is the maximum flooding surface. That is why maximum flooding surface is a downlapping surface. So, if I want to understand what is the overall distribution pattern of different depositional systems across the entire HST within marginal marine to deep marine part, we can understand that with a very simple diagram. This diagram already I have introduced in the last class when I introduced about the overview of the systems tracts, but here I will again refer back to this diagram and I will try to explain now just the HST part in that diagram. So, let us see if this is the fluvial part, then this is the shallow marine part, and then this is the deep marine part. At the start of the HST, the base level was here and it is rising up and it is reaching to level 2. For this much of rise, we are getting some extra accommodation, and due to that extra accommodation, what we will get is the first manifestation that we will get over here is the aggradation of the fluvial systems. So, the fluvial systems which are here at the end of the previous transgressive phase, so on that the fluvial system will try to aggrade over, and along with that it will prograde. So, definitely this substrate on which this is happening, this substrate is the maximum flooding surface which marks the end of the transgression and start of this HST. Now, this sea level is rising up from 1 to 2. So, this kind of aggradation and progradation will continue for several times, and what we get is formation of a delta. So, what we are getting over here in this part, we are getting dominantly aggradation which is associated with little bit of progradation, whereas when we look into this part, we are looking into dominantly progradation with little bit of aggradation. So, if I look at the overall base level curve, so basically we are looking at somewhere here in this part of the curve which indicates the HST, where the base level is rising, and due to this rise extra accommodation is created, and that accommodation is immediately consumed by the supply of sediments which are going on at much higher rate. Now, as we are reaching over here, which may be the part of the outer shore face trending into the self area. So, in this part, due to this additional depth, extra depth of water, so the overall energy condition is significantly decreased, as well as the coarser sediments, they are mostly confined into the marginal part, into the shallower part. So, as a result, in rest of this area, what we get is only the deposition of hemipelagic to pelagic mud. Hemipelagic to pelagic mud, which is commonly deposited in a very low energy condition. rate of deposition of this hemipelagic pelagic mud is very low. So, as a result of that we get relatively thinner deposit, overall thickness of this deposit will be quite less, and commonly these are called as condensed sections. So, this kind of thick or continuous hemipelagic pelagic mud will characterize the entire shelf starting from outer surface to entire shelf, and that will even continue into the deep basinal part. So, in the shelf part, if I try to make a little bit more detailed drawing, so it is the shelf break, this point is the shelf break. So, this is the shelf area and this is the deep basinal part. So, along this entire zone what we will get is the deposition of the same mud, and since this is mud covered, since this is a very low energy condition, so supply of turbidite, supply of the gravity flows over here will be negligible, almost absent. So, along this entire area we will not get any variation, not much variations in terms of the depositional pattern, in terms of the depositional systems. So, major deposition is confined in the marginal marine part, where dominantly we are getting aggradation and progradation of the fluvial system, as well as progradation and aggradation of the delta lobes, which are spreading into the marginal marine area, into the coastal area. They are the main supplier of sediments into this system. So, within this HST part, when this HST is depositing during this particular phase of base level curve, what we are getting? We are getting only variation in the sedimentation pattern over here in the marginal marine part. This particular package which is forming under the HST, this is called as the high stand prism. High stand prism. So, if I want to understand what actually is happening over here in a little bit more detail in terms of the distribution of different depositional environments and the resultant depositional systems. So, further I can try to draw another very simple diagram to understand this one. So, let us think of an ideal marginal marine condition, where say for example, we have a situation like this, where a river system is coming in, and this river system is getting mixed up over here with respect to the sea level, which is at the end of the HST level, and initially the water level was somewhere here. So, it is rising up. So, initially the river was somewhere here, river was supplying sediments over here, and as a result of this, so maybe this is the end of the transgressive phase, end of the TST. So, at that time the river system which was here is gradually aggrading up, gradually showing accretion, vertical accretion, gradually showing aggradational pattern. Along with that, the river system, they will try to distribute the sediments, try to dump the sediments at this river mouth area, and as a result of that, in the river mouth area we get the delta lobe, and this delta lobe will gradually prograde. So, what will be the nature of this delta lobe? It will gradually prograde. Now, when this kind of progradation is going on, along with that there are waves are coming in which brings in longshore currents. So, the sediments will be distributed along the coast, forming strand plains, forming the beach condition. So, we get gradual accumulation of the beach sediments, and as the delta system is prograding forward, the beach system will also prograde forward. So, if this is the delta system, from there the beach system is forming like this, and it will try to prograde gradually. So, when this progradation is going on, along with this the aggradation is also going on as the river system is aggrading up, and as a result of that overall we are getting aggradation plus progradation. Now, all these processes are going on over this area, into this area which is part of the shore environment, and then we are going down to the shelf area, from there the shelf break and the deep basinal part. So, if I draw this one like this. So, this is the self edge. So, this is the slope area and this is the deep basinal part. So, this is deep basinal part. So, when this is happening over here in this shallower part, so most of the sediments, they are getting trapped over here. As the water level is quite high, water level is somewhere here. So, this portion is under significant depth, definitely it is beyond or below the wave base. So, the wave reworking is not going on over here, and also the coarser sediments are trapped over here in this part. So, the sediments supplied by the river forming the delta low, forming the delta mouth bursts, they are all trapped in this river mouth area, producing this gradual progression of the delta system, and along with that gradual progression of the strand planes. Beyond that area, the supply of sediments is very much restricted. So, as a result of that, what is happening over here in these portions? These areas are completely devoid of dominant clastic supply. These areas are devoid of dominant energy condition. Those energy condition, those triggers, agents which commonly produces the supply of sediments, reworking of the sediments in this area, they are completely absent over here now. So, as a result, only the pelagic and hemipelagic mud which is available in the water body, that starts settling down over here. So, we get thick deposit of pelagic and hemipelagic mud as a condensed section. So, we get these condensed sections distributed over this entire zone, starting from the outer shore face to offshore to self to deep basinal part. Since this area is under mud cover now, and this area is not facing any major energy variation, any major high energy processes over here. So, as a result, this area is very much stable now. This self break area, the self edge area is very much stable now. And since this is stable, since we are not getting any high energy processes going on over here, so the supply of high energy gravity flows is stopped now. And since there is no gravity flow, so the supply of coarser sediments are absent towards the deeper marine part, deep basinal part. So, as a result, in the deep basinal part also we get same kind of monotonous sedimentation which is characterized by pelagic and hemipelagic mud deposition. So, if I want to summarize what are the characteristic properties that we can get over here during the HST, starting from the continental side to the marine side. So, number 1 is fluvial system. If I look at over here, the fluvial system is gradually aggregating. So, fluvial channels and the overbank areas, they will be aggregating, and along with that little bit of progression they will face. So, overall we get fluvial aggregation plus progression, that is one characteristic of the HST system. The second criteria, the delta plane. So, as the fluvial system is coming into the tidal regime, as it is coming into the wave regime, so there we get the delta plane system, and this delta plane is also kind of fluvial system itself, and this delta plane is also facing similar kind of aggregation and progression. If I look at the delta front area, delta front is prograding. Definitely it is aggregating because there the characteristic is like this, the aggregation and progression is going on like this. So, definitely there is an aggregation, but along with that we have progression. So, this part is the delta front area, this part is the delta plane area. So, the delta plane is having more aggregation than progression, delta front having more progression than aggregation. So, definitely when this is going on, the sediments are supplied at high rate and these sediments are distributed along the strand planes. So, strand planes are also developing very well and they are also prograding. So, the fourth characteristic is the progradation of the strand planes. progradation of the shoreline, progradation of the entire shore system. Now, as we are moving into the relatively deeper part, starting from the offshore onward, it is a very stable condition, very low energy condition, and that results in deposition of pelagic and hemipelagic mud dominantly. That is characteristic 5. And the final one, we get a very stable self edge condition, and that self edge condition, that stability in the self edge reduces the supply of coarser clastics into the deeper part. In fact, it stops the supply of coarser clastics into the deep basinal area, and as a result of that, deep basinal area is also very stable, and there also we get deposition of mud. So, these are the overall characteristics in terms of distribution of energy system, in terms of distribution of processes, and accordingly we can now think of what will be the phasis architecture, what will be the phasis model in each of these individual environments as per this distribution pattern, as per this energy distribution characteristic. Say for example, if I now think of the fluvial system that will form during the HST. So, what will be the characteristic of the fluvial system? As I am telling you, fluvial system will show aggradation with progradation. So, when this aggradation with progradation is going on in the fluvial system, what kind of phasis architecture we expect? So, there comes the role of phasis model of the fluvial system, and we can understand, looking at that phasis model, we can interpret that what will be the overall distribution pattern. So, if I talk about the fluvial aggradation in little bit more detail, so it is in terms of the aggradation of the channel system and the floodplain system. So, whenever we talk about a fluvial system, broadly we can find out two major depositional area, one within the channel and second one along the floodplain. So, the floodplain areas and channel areas, they can show distinct characteristics in terms of their depositional pattern. So, if I think of a channel like this, and within that channel we can have an overbank area. So, definitely the energy system within this channel is very high. So, we will have high energy flow over here, as well as this overbank area, it is characterized by low energy condition, because here only during high flood condition we get covered with water, and that is a very low energy zone. So, we get relatively low energy floodplain deposits which is dominated by mud. Definitely we can get some sand, but dominated by mud. Whereas, if I look at the channel part, so the channel part is dominantly characterized by sand, because this is the main area where water is flowing. It is carrying the sediments in bed load and suspension load, and due to this high energy current which is flowing through this channel, we get mostly channel fill cross stratified sandstones. So, this channel fill sand, that commonly indicates high energy zone within the channel system, within the fluvial system. The overbank area which is dominated by mud with little bit of sand, there definitely the energy system is much low, and so the bed form which will form within the sands, that will be of much smaller scale. So, within this floodplain area, or maybe we can very often we call them as the overbank areas. So, within these overbank areas or within these floodplain areas, we commonly get relatively dominance of the finer grain sediments, dominantly mud, whereas within the channel part we get dominantly sand, and those sands are basically channel fill sand. So, basically with deposition of different type of sands as a phasis, we get gradual filling of the channel part. So, relative increase in the coastal elevation, relative increase in the base level leads to the aggradation along the shoreline system, and that kind of aggradation that involves progradation and vertical stacking of the distributary mouthbars. And when that kind of vertical stacking of the distributary channels and mouthbars are going on, that leads to the backfilling of the newly created fluvial accommodation, because as the base level is rising up, we are getting extra accommodation in the fluvial part as well, and that extra accommodation, fluvial accommodation, will be filled up in a kind of backfilling way as it is gradually filled up from the seaward side. So, we get progradation and aggradation together. So, that kind of backfilling and that kind of creation of fluvial accommodation leads to decrease in the gradient of the topographic slope, and that decrease in the gradient of topographic slope leads to the lowering of the fluvial energy. So, when this kind of aggradation is going on in the fluvial system, we can think of the overall fluvial energy is significantly low, and when it is low, so there will be more flooded condition than the channel flow, because when it is a low energy condition, that means the water level is very high and that is a flooded condition. So, this kind of trend superimposed on the continued denudation of the sediment source areas tends to generate an upward fining fluvial profile. So, that upward fining profile, that upward fining succession characterizing the fluvial system under this kind of situation continues the overall upward decrease in the grain size recorded by the underlying LST and the TST, because during LST also we commonly get a fluvial onlap, during TST we get a fluvial onlap, and during onlap definitely we expect to get a fining up grain size distribution pattern. So, that distribution pattern is expected to continue over here as well. So, within this fluvial aggradation part, the fluvial portion of the HST is divided into two parts. The first part is the lower part, which is commonly characterized by isolated channel fills engulfed in the finer grained overbank sediments. So, in this part the channel fills, their abundances are relatively less with respect to the overbank sediments, with respect to the floodplain sediments. And if I move on to the upper part of the HST, there commonly we get characteristically higher degree of channel amalgamation, and when channels are amalgamating, the proportion of or abundance of the overbank deposits will be reduced. So, if I think of, say for example, if this is the river profile, this was the base level at the start of the HST. Now, the base level is rising over here, and as a result of that the fluvial profile will try to reach over here. So, this is resulting in decrease in the gradient of the river profile, which will result in decrease in the energy condition of the river profile, river system. And when we have in the initial phase, definitely this rises at very high rate. So, during this phase what we will expect? We get more of aggradation than progradation. We are getting much wider space developed, much higher amount of space developed, and the river will try to accumulate that part. So, during that part, if I think of the channel system like this, and with that we have the overbank like this, and suddenly the water level is somewhere here where a lot of sediments are coming in. So, definitely we will get lot of overbank deposits which will be trying to cover up, and this channel part will be covered up by channel deposits, channel fill deposits. Now, if I try to think of this in a larger scale, so during this HST phase what we expect is we get overall overbank deposits, thick overbank deposits, and within these thick overbank deposits which are dominantly mud, we get this kind of channels which are actually separated channels, because as you can see over here, one channel is separated by this thick mud deposit. So, one channel which is separated by a thick mud deposit, another channel separated by thick mud deposit, and it is going on like this. So, in the initial part what we get is commonly distribution of the channel system like this. Channel fills, they are relatively less in abundance with respect to the overbank deposits. So, we get more thicker overbank deposits than the channel fills, whereas as we are reaching over here in the upper part of the HST, where the space is now more easily consumed, more easily occupied by the river sediments. So, now in this part the flooding event will be relatively less frequent, and as a result what will happen? Now, the channels will be more frequently amalgamated, separated by some floodplain deposits. So, these are some floodplain deposits, and in between that we get this kind of channel deposits. So, now the channel deposits, they are amalgamated more frequently with respect to this part. So, this we will get in the lower part of the HST, where aggradation is going on at higher rate with respect to progradation, and this kind of scenario where multiple amalgamated channel fills separated by some overbanks, intermittent overbanks. That will be the characteristic of upper part of the HST. So, in the fluvial part, if I look in terms of the HST, we can get this variation starting from lower part of HST to the upper part of HST. So, when we look into the aggradational component, that is during the early phase, the ratio between the floodplain deposit and the channel fill deposits, they will be relatively high. That means, the floodplain deposits will be more abundant with respect to the channel fill deposits. When you look into the late phase, that is the more dominantly progradational components, there we can observe there is an increase in the channel clustering, and implicitly we can see a change in the ratio between the channel fill and floodplain elements. So, definitely in that case, the channel abundance, channel fill abundance and their amalgamations will be more abundant with respect to the floodplains. So, the progradation process, it commonly accelerates with time during the high stand stage. So, this is in parallel with the decrease in the rate of base level rise and the corresponding decrease in the rate of creation of fluvial and marine accommodation. Just think of, as the base level is gradually reaching to its maximum level, and there just think of that curve. So, it is nearly getting horizontal at that place. So, the rate of change is very low. So, the amount of accommodation now being created at this phase, when it is reaching to the peak, reaching to the maximum of base level rise, then the rate of creation of the accommodation is very low. But we are getting large amount of supply of sediments into the system. So, there is a scarcity of accommodation now in terms of sediment supply, and those sediments will try to get accumulated within the channel systems. So, what we get now, we will get more progradation and amalgamation of the channel fills. There will be less amount of flooding, less frequency of flooding, and as a result of the abundance of the floodplain deposit, abundance of the overbank deposits will be less. So, when we look in terms of the grain size distributions, the maximum grain size transported by the high stand fluvial system, that decreases with time, because as at the initial phase we have lot of accommodation available. So, there will be lot of supply of sediments, but as the system is gradually aggregating up, what we get is gradual decrease in the slope, and that decrease in the slope results in, that decrease in the gradient of the river profile results in lowering of the energy, fluvial energy, and due to this lowering of fluvial energy, the supply of sand fractions or coarser fractions will decrease. So, if I want to try to make a graph of the sand mud ratio, so that ratio will gradually increase in response to the decelerating base level rise and the corresponding increase in the degree of channel clustering. But when I look into the distribution of the sand fraction only, then definitely the size of the sand fraction will decrease as we move upward. So, overall what I get is finding upward vertical profile within individual units. Within individual depositional systems, we get finding upward vertical profile, but when I look into the overall pattern, it is a coarsening upward pattern. So, the high stand fluvial systems, they can have a limited preservation potential due to the subsequent subaerial erosion during the base level fall, because during the base level fall already we have discussed during our class on subaerial unconformity. There we have seen that how much erosion is going on, that is the main factor. So, that determines that how much of the HST will be preserved. Many times if the erosion is extremely high, then the HST package may get completely eroded. So, the high stand fluvial systems, its preservation potential is limited, controlled by the erosion going on during the next forced regressive phase. However, in between the channels, because during this erosion the river incision takes place along the channels, but the interflow areas, the overbank areas of this kind of incised valley systems, they are relatively less affected by erosion during this forced regressive phase. So, the top of the non-marine HST part, that may get preserved that we can find out within these interflow areas. There is a high chance that these HST portions are preserved within these interflow areas, not within the channels. But when they are preserved in the interflow areas and they are bypassing this incision process during the forced regressive phase, sometime these HST deposits get changed into some pedogenic processes, they get changed into some soil forming processes. So, overall during the HST phase, if I look into the fluvial component only, so there we get a very complex pattern. So, apparently it is an aggradational to progradational pattern, but in general we get a changeover from the lower part of the HST to the upper part of the HST. In the lower part of the HST, we get more aggradation of the fluvial systems, resulting in higher overbank deposits with respect to the channel fills. So, channel fills are separated, they are segregated, whereas as we are moving upward within the HST, the accommodation is decreasing. So, it is resulting in a more competition of occupying the accommodation by the channel system. As a result of that, there will be less frequent flooding, and that will result in more amalgamation of the channel fills with less abundance of the overbanks. So, we will continue this discussion in our next lecture, where we will look into the other areas in terms of the HST component, other parts of the basin, what kind of depositional condition prevail over there and what are the characteristic sedimentary packages that we commonly get. So, these are some of the references for your further study. Thank you everyone.